For many years, medical doctors have obtained eye pressure readings through the cornea. Today, we are starting to obtain corneal values by measuring interocular pressure. But how has this become possible? Before beginning, let's return in time about half a century. Already at that time, Goldmann alerted all that readings made on his equipment could be wrong when examining abnormal corneas. Goldmann's tonometer derives its readings by compressing and flattening a central portion of the curvature of the cornea. To achieve this, the Goldmann tonometer must overcome two principal obstacles: the resistance of the cornea, the resistance of the eye's own interocular pressure. Today, doctors all over the world discuss the dependability of Goldmann's tonometer in reference to corneas that may present any type of modification in their anatomical or biomechanical properties. Such properties are thickness, the property or characteristic that initially attracted the attention of doctors. It is a fact that thickness interferes greatly in the total rigidity of the cornea and is easily obtained through ultrasonic pachymetry. Curvature. Studies show that a change of just 1 dioptria of astigmatism can elevate the Goldmann tonometer reading more than 0.5 millimeters of mercury. Diameter. Changes in the diameter of the cornea can also create errors with the Goldmann tonometer. Elasticity. Look at how metal resists tension. When force is removed, its rigid structure returns to its former shape. The cornea also has this property. That is, it will return to its original form after tension has been applied. Viscosity. Here is a perfect example of viscous material. Observe that in some material the form may always be changing as a result of force without returning to its original shape. But in viscous materials, any force applied to them is dissipated and absorbed by its intrinsic resistance. As such, all viscous material, including the cornea, possesses its own coefficient of viscosity. Hysteresis appears to be a sub-property of viscosity, that is, one property within another. As we know that when the eye suffers some type of deformation, such as in a trauma, the corneas give off energy absorbing the impact, and this happens as much in the going as in the returning movement. Age. Increase in age also increases rigidness. Density. Even though these corneas have the same thickness, the more dense is more rigid. Experiments with pigs.
Does whatever a spider pig does. Can
No,
he swing
not that
from
one.
a web?
An experiment with the eyes of pigs. A fixed 30 millimeters of mercury interocular pressure was monitored by an anterior chamber probe. The IOP measurement with the Goldmann tonometer was 35 millimeters of mercury. After the glutenaldehyde application, the IOP measurement using the same tonometer was 80 millimeters of mercury. We know that the Goldmann tonometer is sensitive to the mix of corneal properties. It measures, of course, the interocular pressure multiplied by the mix. New tonometry technology of dynamic contorno, represented by the Pascal tonometer, is capable of measuring interocular pressure with little or no participation of the cornea. It's a simple concept. The weight of the total less the weight of one element can only result in the weight of the other element. And so, the Goldmann tonometer measures the total of intraocular pressure plus the corneal mix. The Pascal tonometer measures the first element, interocular pressure, which when subtracted results in the value of the corneal mix. The mix will always be less than 1, since the cornea is less rigid. A fictitious, exaggerated example would be the following. If we find 10 millimeters of mercury with the Goldmann tonometer and 20 millimeters of mercury with the Pascal tonometer, the difference can only be explained by the cornea, and if we divide the Goldmann measurement by the Pascal, we will encounter the half value, or rather the cornea, with half the rigidity. Using this method, it will be difficult for the values of the rigidity of the cornea to pass above 2 or below 1/2. RIGITEST. Weight. To facilitate our gaining of knowledge and organization of information, the RIGITEST was created, a registered software that received the data from each patient and compared it with stored reference values. The program organized the data such as names, sex, age and color, type of surgery, Goldmann tonometer values, Pascal tonometer values, pachymetry, the presence or absence of keratoconus topography, and classification of data in pre- and post-operation. Some 200 patients have already been analyzed with this software, producing such information as the RIGITEST was sensitive to corneas that presented keratoconus. Many other interesting observations were obtained, and new scientifically oriented studies are being carried out, the results of which will be published in the near future. In conclusion, the biomechanical properties of the cornea open a new window, bringing new information that may become indispensable to preoperational safety in refractive surgery, as well as a new source of information for post-operative care of our patients.